In the last question, we looked at how to find the potential energy stored in a spring using the usual formula, right, which is half kx square. And now we are going to look at a very similar question, but how to find the potential energy stored in a spring using graphs. Okay, so one way of finding the potential energy in the spring is half kx square. We use that the last problem. But now, if we have a graph which is f versus x given, we know that the work done, right? We can compute the work done by simply finding the area under this curve, right? So this question is going to use the same concept to answer pretty easily. Okay, so let's look at this. The graph shows how the tension force F in a spring varies with extension X, right? So we are pulling the spring with some tension force, and this force is varying with a distance X, and we have given this graph. We have to find the work done to stretch the spring from extension 5 centimeter to an extension 15 centimeter. So it is very similar question like the last time from 3 to 5 centimeter. Here now it is 5 centimeter to 15 centimeter, right? So whatever work is done by this force is getting stored as a potential energy, right, in the spring. So if you want to know how much work has been done from 5 to 15, first we look at the x-axis and we find our 5, which is here, and this point over here is the force, right? And this, I think that's 6. So this is the location. And then it goes to 15 centimeter, which is over here, 15 meter, and which actually cuts very neatly here, which is 15, 16, 17, 18. Okay, so this is 18 here. Okay, now to find the work done in stretching this spring from 5 to 15, all we need to do is find this area under the curve. Okay, this area which is under this curve. Okay, we have to find this area, and as you can see, this area has two parts. So one is a rectangle, which is like this, right? So this one, we are going to take it away. So this rectangle, and we take the sides. So this length on the x is 0.15 into 0. So this is 0.1 meters, and height is 6 newtons. Okay, so the area here, we multiply it simply. This is going to be 0.6 Newton meter, right? Joules. And this triangle, we are going to take this triangle away again. It's always better to neatly work it separately, right? That way it becomes easier. The base again is 0.1, as you can see from here, and the height is going to be 18 minus 6, right? 18 minus 6, and that will be 12. To find the area, we're going to do half into 12 into 0.1. This and this is going to be 6. 6 into 0.1, again 0.6 Newton meter, and this is the area we are looking for, right? And that is going to be equal to the work done. 0.6 plus 0.6 is going to be 1.2 Newton meter, and that will be the work done in extending the spring from 5 centimeter to 15 centimeter. Okay, so it's always easier when you are given this graph, right? We just look at the area, we find it even without using half kx square. You can arrive at the answer very shortly. All you need to do is be careful while calculating this area. If you draw the separate parts of the area separately, mark the distances correctly, then it's just a matter of using the formulas to finding this area.